Hello everyone, welcome back to my channel Saisha. This is Amok Kaliva. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about gradient descent, how gradient descent works, how to find gradient descent minima value using calculus, thereafter different types of gradient descent and a practical applications of an example. In today's video, we will be understanding about linear regression, what are the assumptions which we make in linear regression, how to build a hypothesis and cost function of a linear regression. Thereafter, we will also be learning about concepts of residual errors, what are the properties of residual errors and different types of linear regression. Linear regression is the most primitive and widely accepted model in data science and machine learning, and it is the first choice of an interviewer in data science or machine learning jobs. So, what is linear regression? Linear regression, it is a supervised learning. Here, supervised learning means the learning between the independent variables and the dependent variable. Independent variables such as age, geography, persons, etc. Whereas the dependent variable is the package which you consider in your phone. Here we are predicting the package in your phone. So, linear regression, it is a supervised learning which builds linear relationship between the explanatory variable and the dependent variable. Explanatory variable are the independent variables and dependent variable by fitting a linear equation. For example, if your data is spread in the plane of x and y, we are considering x as the independent variable, y as my dependent variable. Then we build a linear equation. This linear equation can be represented as linear regression model. Here, this linear equation can be transformed into mathematical formula. That is, y is equal to theta 1x plus theta 0, where theta 1 represents the regression coefficient. Or you can also say the slope of the line which you are building. And theta 0 is a constant or the intercept. In this case, this point can be represented as theta 0. These were some of the concepts of linear regression. Now, let us understand the assumptions which we make in linear regression. There are four important assumptions which we make during building a linear regression model. Those are linearity. There should be a linear relationship between the independent variable and the dependent variable. That is, if there is a change in y, that change is due to the change in x, that is independent variable and dependent variable. Similarly, multicollinearity. There should not be a linear relationship between the independent variables. For example, if we have a salary of a person in months and similarly salary of the person in years, there will be a relationship between the two. During modeling, we should eliminate any one of the attribute. Independence of errors, which means there should not be a linear relationship between the residual errors. And lack of this type of assumptions in the residual errors is known as autocorrelation. Homoscedasticity, which means there should be a constant variance between the error terms. which is represented as shown in the figure. And the lack of this constant variance is known as heteroscedasticity. These were some of the assumptions which we consider during model building. Now let us understand the error terms, that is residual errors and the properties of residual errors. Residual error. Residual error is the error generated between the actual value and the hypothesis line which we model. For example, if we are building a hypothesis line for a data set, that is a linear equation, the projection of the value of actual onto the linear equation, that difference is known as the error and is also called as residual error. Now we have some of the properties of residual error. For example, the error terms are normally distributed. Normal distribution, which means that there are same number of error terms before and after the mean, median and mode. For example, the left side of the median is replica to the right side. The values on the either side are equal. Similarly, consider if we have two error terms, like the one error term is +2 and another error term is -2. So, if we take a summation of all the residual errors, then these two terms cancel out each other, which is not required during assessment of the model. Hence, we take always the square of the residual errors so that the error terms do not cancel out each other. These were some of the concepts of residual error. Now let us understand how to find the best hypothesis line using cost function. Choosing a best hypothesis line for a linear regression, which is mathematically represented as y is equal to θ0 plus θ1x, where θ0 and θ1 are the intercept and the slope of the line. With the different values of θ0 and θ1, we can draw numerous hypothesis lines. But to choose the best hypothesis line for the data set which is present, we can use cost function. The cost function is represented as j, and the values are hypothesis line minus actual value, the whole square, which means the predicted minus actual value, the whole square. Here we take square of the values so that we do not cancel out the error terms in the data, which is summation over all the error terms and divided by the number of error terms. This is how a mathematical formula for a cost function is represented. In a linear regression model, the cost function is a quadratic. Now, let us consider a θ0 and θ1 value, which is represented as this point on a cost function and this hypothesis line. To get to the minimum error term value, we take the derivative of the point of the cost function and multiply it with the learning rate to get to the next minimal value. Here the derivative provides us the vector to move in which direction where the error terms are least. We reiterate the same procedure at point 2 to arrive at point 5. Here 0.5 is the best hypothesis line because it has least error, that is residual term error is least as compared to any other hypothesis line which is built for this data set. Similarly, if we start at point number 3, we go to point number 4 and then towards 5. This is how the cost function helps us to build best hypothesis and linear regression model. In all the scenarios, we have considered only one variable as independent variable. If we consider more number of independent variable, let us understand how the cost function and the hypothesis equations get modified. In multivariate linear regression models, you have multiple independent variables like age, school you have attended, the income level which you have, the job which you have. So these are different independent variables, but there is one target variable or dependent variable which can be represented as, here h is equal to theta 0, which is the intercept of the variables. Theta 1 is the coefficient for variable 1 x1, theta 2 is the coefficient for the variable x2 and so on. And the vectors for theta is represented as theta 0, theta 1, theta 2 to theta n, and for vector x is represented as x1, x2 and so on. The hypothesis for a multivariate linear regression is h is equal to theta t of x. Similarly, the cost function and the derivative for the cost function also get modified for multivariate linear regression, wherein you replace the hypothesis with the new hypothesis for the regression. This is how multivariate regression equations get modified. These were some of the concepts of linear regression model. In the next video, we will understand the practical application or model building of linear regression in R. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.